antibodies, some of which even worked, to make them well. But too often, the cures they tried were completely useless. Today, of course, most people like to think that the doctor can cure anything. And that's partly true. Doctors can fix many things. And that's important to remember.
Mm-hmm.
But did you know that your own body usually can and does take care of most things that go wrong all by itself? That's right. Your body has its very own built-in magic doctor. A doctor with more than 3 million years of experience. And in all that time, your magic doctor has learned some pretty amazing things. Let's take a look at how it all works. You might think of your body as a kind of well-protected fortress. A fortress with several gates or openings. An opening such as the mouth, for example, admits the food we need to grow strong and stay healthy. And of course, as with a fortress, there are always lots of things trying to get in. A whole invading army, in fact. The bacteria, viruses, fungi, and parasites, and the chemical and other poisons that exist all around in our environment. Fortunately, our fortress is well protected. Our skin, for example, doesn't let most invaders even get past the surface. And simply washing regularly gets rid of millions of germs. Germs in the air, which try to enter our body through one of the other gates, also have a tough time. Our nose, for instance, has tiny hairs inside, which serve as guards to keep out invaders. Our eyelashes and eyelids keep away more germs, and the nose and mouth both have mucus to trap invaders, kind of like the moat around a fortress. Sometimes when our enemies do manage to get inside, our body instinctively tries to get rid of them. We sneeze or vomit, or perhaps our eyes fill with tears. But what happens when an invader does succeed in slipping completely past this first line of defense? That's where your magic doctor comes in. The immune system's main defending army consists of your white blood cells, and there are millions of them. Many of these travel throughout your body in the circulatory system and the lymph system. White blood cells, along with red ones, are manufactured in the bone marrow inside some of your larger bones. Each kind of white cell will have a different part to play in defending your body, and each kind has a different name. Some will become macrophages, and these will be distributed to all the tissues of your body. Other white blood cells go in separate directions to become T or B cells. The future B cells travel directly to special areas called lymph nodes, located in various parts of your body. The future T cells travel to a gland located near the heart called the thymus, where they sort of go to school to learn how to become special kinds of T cells, helper T cells, killer T cells, and suppressor T cells. All the different kinds of white cells work together and keep in touch through a marvelous communication network. They're all part of your magic doctor, and their main job is to identify and destroy any invader that's not, or shouldn't be, a part of the human body. Now, let's take a look and see what happens when invaders do slip by the first line of defense. That's where your immune system, the army of white blood cells we've just met, swings into action. The first sentries an invader might meet are the roving guards called macrophages. Some invaders, such as most bacteria, for example, are simply destroyed on the spot by these macrophages. Under a very powerful microscope, it would look something like this. The macrophage actually engulfs and then eats an invader, turning it into harmless pieces. This is routine work for the macrophages. They are scavengers and are constantly destroying all kinds of outside invaders and cleaning up inside the body. We just never notice when they do their job well. Certain invaders are so powerful, or there are so many of them, that lots of macrophages are actually killed in the battle. Too much cigarette smoke, for example, will overpower the macrophages and damage your lungs. The macrophage sentries can also recognize that some enemies, certain bacteria for example, are too strong for them to handle. So they immediately call for reinforcements from the rest of the immune system. The white blood cells, called helper T cells, are the first to respond. Their first step is to identify the enemy. They do this almost like a detective. Each invader is recognized by a special code or mark, kind of like a fingerprint, which will aid in its identification. These markings are called antigens. As soon as they know exactly who the enemy is, the helper T cells call for more help from special white blood cells called B cells, who have set up shop in the lymph nodes. Certain B cells immediately begin producing antibodies, special substances which match the antigen of the invaders. The antibodies attach themselves to the antigens of the invaders. And once the invader is marked or neutralized by the antibodies, other cells, including the macrophages, come in to destroy him. With a powerful microscope, we can watch it all happen. Antibodies hook up with the antigens on the invading bacteria, making them defenseless and vulnerable to the macrophages, who rush in to finish the job. Viruses such as those that cause colds, for instance, are sneakier than bacteria and harder to get rid of. Viruses actually take over regular cells in the body so they can grow and multiply, destroying the regular cell in the process. When this happens, the sentries call in reinforcements, the killer T cells. The killer T cells kill the host cells, the ones which were taken over, and the invading virus along with them. Antibodies lock on to any remaining viruses so that macrophages can eat them up. And once again, under our microscope, it looks pretty much the same. Killer T cells work together with antibodies produced by the B cells and with the macrophages, and the virus is destroyed. When the defenders have won and the invaders have been defeated, another part of the immune system's team, the suppressor T cells, step in to bring an end to the fighting. Then our garbage men, the macrophages, clean up the debris, and everything goes back to normal. Except that special memory T cells stick around to remember that particular invader's fingerprints, or antigens. So if another invader of the same kind ever returns, the team will be able to fight back much quicker, with less time wasted and less damage done to other cells. This is what we call immunity, the ability to resist a particular disease. Although your magic doctor responds differently to each particular invader, those are the members of the defending army. The macrophages, helper T cells, killer T cells, B cells, and suppressor T cells. And of course, the memory T cells. But as amazing as the immune system is, it sometimes doesn't work as it should. Sometimes the immune system makes a mistake and attacks harmless visitors, such as food that we eat, or pollen from plants, and we develop symptoms such as swelling, itching, rashes, or a runny nose. We call these reactions allergies. Sometimes, but not very often, the system makes a mistake and attacks normal cells. This is what happens in autoimmune diseases, such as rheumatoid arthritis or multiple sclerosis, where the immune system attacks certain parts of the body. Sometimes the immune system fails to recognize invaders, and we get sick. Cold and flu viruses change so often that the sentries have a hard time recognizing them. This can also happen with cancer cells. Cancer begins when some of our normal cells mutate or change, creating cancerous cells. Sometimes this occurs naturally. Sometimes it's caused by poisons in our air, water, or food. Usually these mutant cells are routinely destroyed by the immune system. When these cells aren't caught and they begin to multiply out of control, we develop cancer. Sometimes one or more parts of the immune system are missing or defective. Some children, who we call immunodeficient, are born without natural inner defenses and need special protection against bacteria and viruses. Since their bodies can't fight off even simple diseases, they can get very sick and even die from minor illnesses. Sometimes a part of the immune system is destroyed, thus crippling the whole team. This is what happens when the AIDS virus destroys the helper T cells, which would normally call in reinforcements. That's why people with AIDS can't fight off invaders. But even when the immune system works as it should, sometimes the invading bacteria or viruses are just too strong, and the immune system needs outside help. Doctors can give us antibiotics, medicines that help kill bacterial invaders. Immunization is another way doctors use their knowledge. Immunization fools the immune system, making it think there's a dangerous invader, when in fact, there's only a harmless decoy. Okay, let's explain. In the case of smallpox, for example, the doctors made a vaccine out of another very similar disease, cowpox, which made cows sick, but not people. The two diseases looked so similar that they even fooled the immune system. When people were given a dose of the cowpox virus, their immune system produced antibodies to match it. And after the cowpox virus was destroyed, the memory T cells were ready so that if the person was ever exposed again to cowpox or to smallpox, they could fight it off easily. Because of this vaccine, smallpox is a disease that no longer exists in the world. As modern scientists discover exactly how the many parts of the immune system work, they are able to use that knowledge to fight disease. Much of the current research on cancer and AIDS, as well as other diseases, focuses on how to protect and strengthen the immune system to help it fight better. Scientists are now studying the chemical messengers in the immune system's communication network in attempts to prod it into action when it's weak or has failed. And now that they understand how antibodies bind to invaders, scientists are creating magic bullets by attaching strong poisons to antibodies. The magic bullets attach to the invaders, taking the poison directly to where it's needed. Scientists are also experimenting with decoys to fool invaders, so that, for example, the AIDS virus would attack the decoys rather than the helper T cells. The more we learn about how the immune system works, the more ways we'll discover to fight diseases. Because the invaders are so small, we don't see them, and we're not usually aware that these wars are going on inside our body. But there are clues. When we notice symptoms, most often what's actually happening is that our body is working to fight an illness or injury. Our magic doctor has a variety of signals to let us know that he's busily at work. Redness and swelling are signs of healing. Sunburn damages the skin. The red color comes from blood that rushes to the area, bringing white blood cells to begin the healing process. That's also why we often see a red color with sore throats or with other injuries or infections. When you get stung by a bee, the bee leaves a little poison under your skin. Again, white blood cells rush to the area to gobble up the poison. The bump is caused by all the extra white cells building up around the wound. When we are hurt or get a bump, this swelling is also caused by extra blood cells and lymph fluid that race to the area to remove damaged cells so they can be replaced by new ones. Swollen lymph nodes, such as you get with an earache or a sore throat, are a sign that the white blood cells inside the lymph nodes are very busy defending against some invader. If you happen to cut yourself, the white blood cells will eat up any germs from outside that work their way inside through the cut. The white pus we sometimes see around wounds or infections is actually just dead white cells left over after a battle. A scab will form over the cut, and new skin cells will eventually grow back. It takes about a week for a cut to heal. Some damage takes much longer to repair. When cigarette smoke damages your lungs, for example, it may take years without smoking for the lungs to heal. Fever is another tool the body has to fight infection. One of the signals the macrophages send out when they spot an enemy can cause fever. Fever seems to both slow down the invaders and speed up the macrophages, making the invaders easier to overcome. And it may slow you down, too, a signal to give your body the extra rest it needs in order to heal. So instead of seeing all these symptoms as problems, you might see them as signs that your magic doctor is hard at work, doing what he's meant to do, fixing whatever is wrong inside your body. And there are lots of things you can do to help your body stay well, fight off disease, and heal from injuries. You know how people often tell you to eat good food and get plenty of rest and exercise? Well, now we know a lot more about why those things are important and how they affect the immune system and the rest of the body. Good food, filled with nutritious proteins, carbohydrates, fiber, vitamins, and minerals, is needed by all the cells of your body, including the white blood cells that will stop the invaders, and the new cells that are constantly forming. Exercise helps the body use the food we eat in a better way, and it can also help reduce stress. Too much stress can be harmful. Too much worry about schoolwork, your sick cat, or your friend. Rest is also important, especially when you're sick. And there are several other things to remember. Cleanliness can get rid of many germs before they're able to get inside your body and cause disease. Avoiding another person's sneezes will also help keep out invading bacteria and viruses. Smoking, drugs, and alcohol can all harm your body, sometimes more than even the immune system can repair. Unsafe sex and the sharing of drug needles are the main ways that AIDS and some other serious diseases are spread. And when your magic doctor needs a friend, remember that your real doctor's there too, ready to lend a hand when your immune system needs extra help. But remember that perhaps the most important help is the kind you can provide by learning to relax, eating good food, getting plenty of rest and exercise, and by paying attention to what your body's telling you. And as you do these things, you can just imagine that your very own magic doctor is working like mad to help you, because he is.